All right, so how do you do this? It's easiest to see things on Excel. It's quicker on Mathematica. So my suggestion to you is on the DLA, use Excel. But for calculations on a WPR, I would use Mathematica because speed, you have limited time. So let's go to this, put this model in here. So I am going to snip this out. I'm going to use Excel because I don't have a time limit. So copy, and then let's go to Excel. We've done this a few times, in at least in my class we've done it, because it is not a good idea to do this for the first, you want to see it a couple times. Let's put that here, reduce the size, so you can see it. All right, so n goes here, a sub n, b sub n. Let's put here like bull, bear, and recession, not a sub n, b sub n, c sub n, because it just gets confusing. All right, so 0 goes here. I'm just going to put sum here, just like I did with my Markov model before, so I know what's really going on. So I make sure that I track everything. 0.6, here I get, my initial condition was 0, 1, 0. That was given to me, that was the last thing I did in the previous part. Here I put equals A2 plus 1. Here I put equals, and I'm going to type in the equation. 0.65 times the bull economy. The bull economy previously was in cell B2, plus 0.30 times the bear economy. That was C2, plus 0.45 times the previous recession economy. That was D2. Do the same for bear. Equals 0.25 times bull, which is B2, plus 0.55 times bear, which was C2, plus 0.45 times D2. And then here, I'm going to put 0.10 times B2, plus 0.15 times C2, plus 0.40 times D2. And then, just to check, I'm just going to add these up. B2 plus C2 plus D2. And then I'm just going to scroll this down. My total probability still adds up to 1. Let's now highlight all of these and then scroll it down. I think they want a whole bunch of stuff. Let's just scroll it down. My sum didn't add up to 1, so that's not good. See, 0.65 plus 0.30 plus 0.4. Oh, see? I catch my mistakes. That's 0.15 that goes here. Make sure, okay, let's do this again. Just a trick. If you want to do this, you just go double click and it will automatically. See, I knew I made a mistake by just tracking my sum. My sum of all of these possibilities has to add up to 1. Why? Because you're either going to be in a bull, bear, or recession. If those total probabilities have to add up to 1. There's no other possibility. So I know that. So it's a way for me to cross-check myself to make sure I've typed it in correctly. And I found my error that instead of putting 0.15 here, I have 0.15. I put 0.45 and it was wrong. And so it didn't total up to be 1 and I caught my error. So that's why I do that. All right, so let's go look at the questions that were asked. The first question that was asked was, what does your model predict for the probability that the U.S. economy will be in a recession in 2018? In 2018, that's 3 years after. So if I want to put this as years, I could do this, 2015. And now 2018 is right here. I can see it. And then I highlight that. And they want the probability that's in a recession. It's 0.174. I forgot what it was, like 174. telling me to move it. It's good enough. You see it. You see the answer. What does your model predict for the probability vector in 2065? Well, let's go look. 2065 is here. So this is my probability vector right here. I can put this over here, paste. Whoops, didn't want to do that. Let's see. Copy. Paste. Now you have to put this in vector form, so I'm not sure how you're going to enter it. I'm sure there's a way to enter it. There's something there. But we usually list our vectors in the form like this with an arrow, P sub n. And then we put it in long notation like this. So bear with me, I just want to make sure that you have the right notation here. Let's see. It'd be 0.42, 0.41, and then 0.17. Depending on where they want you to round it. And then, of course, I don't want to leave this naked. Wonder if it'll let me do this. It didn't like it, so let's see. There, it did it now. There we go. So this is 0.50. Now what's the equilibrium vector for the system? You are not going to get, if you go to the I minus A stuff we did last time, you're not going to actually get that this is going to be a system that actually is invertible. The I minus A is the identity matrix is not going to be invertible. But I'm going to show you one small trick. There's at least for the problems that you have, you are going to find that these things are going to converge to the equilibrium vector if it converges. That is true. Like if it converges to something, it's going to converge to an equilibrium vector. Since you already have this done, and guess what? This guy is your equilibrium vector right here. So if it converges to something, it must be an equilibrium vector. So I'm going to copy that and paste that. So you can get everything once you have the Excel file, you have everything here. I'm not going to change this over. You know, they want it here, but you can also get this with, you're going to get free variables and you have to do this with Mathematica, but this is the cheap way to put the answer in without having to do that. You're going to have to learn to do that anyway, so I have no problems telling you that right now. And look, it's pretty much already converged with P sub 50. It's, at least as far as engineers care about, this is as far as it's converged. We know that it can't actually hit the equilibrium vector. There's a theorem that says that. You're just going to approach it, but this is close enough. All right, so I hope that helps, and this is a hard one, so text me if you need help.